Hello, this is a quick tutorial on 5.6b1. We're going to use the multiplicative inverse to isolate the variable and solve this. So first thing I'm going to do is I'm going to get rid of this number 10 here, the problem number, so that you're not confused by that. We have x divided by 10 equals 3. Well, I know the answer is 30, and trust me, I don't care about the answer. These are simple problems that you can do in your head. We're using simple problems so that you learn the process. What we need to do here is we need to get rid of divided by 10. And the way we get rid of divided by 10 is to multiply by 10. So we're going to multiply by 10 on this side, and we're going to multiply by 10 on this side. Now really what we're doing is we're multiplying by 10 over 1. Okay? So, and we can really think of this as a 1x up here. So when we were to multiply this out, we would actually end up with, and I'm going to write it here and then I'm going to erase it and do it again, but we're really multiplying 10 times 1 is 10. 1 times 10 is 10. We got 10 over 10x. 10 divided by 10 is 1x, or just x. Okay? I'm going to do that one more time, so you see if you can understand that. 10 times 1 is 10. 1 times 10 is 10. 10 over 10 x. That's 10 divided by 10, which is 1x, or just plain x. So that's what I'm doing when I'm crossing these things out. And I'll show you something else in a minute here. So cross those guys out. We have x on this side, but we have to do this. We can think about this as well. 3 times 10 would be 30. 1 times 1 would be 30. 30 divided by 1 is 30. So we have x equals 30. Yes, we've proven that. And you want to think about railroad tracks here, you can certainly do that. All right, well, let's take a look at one other thing that sometimes kids get mixed up on. I'll just put it over here. X divided by 10 is the exact same thing as 1/10 x. So if it makes it easier for you to understand and write x over 10 as 1/10 x, you can do that. And then maybe when you multiply by 10 over 1, you can see the cross out a little bit easier. Okay? All right. I'll do that. I'll model that for you on this next one here. So we have 7 equals m divided by 4. So I'll just rewrite this problem. I'm going to say that this is 7 equals 1/4 m. All right, now the way I get rid of 1/4 m is to multiply by the reciprocal, which is 4 over 1. We can just call it 4. All right? You know what? Let's call it 4 over 1. You can see my 4's and my 1's cross off. I've now isolated it. I've just got m equals 4 times 7 is 28, with 28 over 1, because multiply across there. 28 over 1 is just simply 28. And again, you could just pop it in there and just see if it makes sense. 28 divided by 4 is 7. Here, I can pop it in up here too. 30 divided by 10 is 3. Okay, I'm going to go down and take one a little bit lower down so I can clean up my work area a little bit, and I'll show you a little bit shorter way. When I do these problems, when you understand what you're doing, we allow you to take a shortcut. Here, we'll just do this one here. This one here, we can we know we need to multiply by 5 on both sides, so we can just multiply by 5 on both sides, and just cross the 5's off like this. Draw that bar. We know that we've isolated t. 5 times 8 is 40. Put in the railroad tracks you can. Those are optional, of course. I kind of like them. All right. Yes, you need to show that. You're showing all kinds of things when you do this. And so I'm going to take the time to go through and show you and explain to you why you need to show these things. First of all, on this problem right here, when you solve the way I'm about to solve this problem, you are first of all showing that you understand that because this is a fraction, you multiply by the reciprocal of that, or the multiplicative inverse, you are going to not find out what 3/4 of a c is, but you're going to find out what a whole c is. So you're showing them that. You're also showing that when you multiply by 4/3 on this side, you're showing that you understand that when you balance an equation out an isolated variable, if you do something on one side of the equation, you have to do it on the other. So divide by 3 here to make it a little bit easier. 4 times 4 is 16. Draw my bar, my railroad tracks. C equals 16. All right, I'll do one more here. We'll do 6/7 here, so I'm going to get rid of this. So that's not my way. I want to multiply both sides by 7/6. Cross these out. I've got C equals, divide by 6 is 1, divide by 6 is 3. 3 times 7 is 21. Oops, that bar is kind of wonky. Actually, the bar's not bad. I'll move my 21 over. It's my 21. All right. Ooh, let's take a look at 20. Could get ugly. We're just going to stay with it. Again, we're trying to get h by itself. So I don't care what 3/4 of an h is. I want to know what a whole h is. So I'll multiply by the reciprocal on both sides. These guys cross off. That's the easy side. You got h. But now we can still do some dividing here. I can divide by 4 here. It's 1. Divide by 4 here, it's 3. So now I have 1 times 11 is 11. 3 times 3 is 9. I have 11 ninths. So 11 ninths is the same as, it goes in there one time, there's 2 ninths left over. And that's what h is. Same thing down here for number 23. Now this is a decimal. Don't let it phase you. I mean, these are the same type of problems. So I'm going to multiply both sides by 5. Okay, now you can use a calculator here on the decimals if you want. We won't test you on that, but we know that these are going to cross off, and we know that we have n left. But this is really 5 times 0.6. Well, we can think of that as 5 times 60 cents. 5 times 60 cents is $3. You can write it with 3.00, you can just write it as 3. There we go. 3 equals n. Not sure? Grab your calculator and you can try it. Or, not sure, you can multiply the decimals. 5 times 0.6. 5 times 6 is 30. You have one decimal spot on top. So you just have to go to the end of it, move your decimal one place, and you get 3.0. Okay? All right. Good luck on that one.